Today we're going to look at solving systems of equations by graphing. So we're going to learn what a system is, what a solution to a system is, and how to solve it. So a system is two or more equations that are taken together. In order for something to be a solution, it has to be true for all equations. The solution is a point or an ordered pair in most cases. And when we're solving by graphing, it's where the lines intersect. And when we solve it by graphing, we're going to use any method that we've previously learned to graph the equations. So anything we learned in the second unit is fair game. All right, so in this case, we have both of our equations in slope-intercept form. Remember, that is y equals mx plus b, where m is the slope and b is the y-intercept. So in this first equation, there's nothing in front of the x, so it's 1, and then our y-intercept is 3. Okay, so I'm going to go up to 3, and my slope is 1, so up 1 and over 1, or I go down -1 and back -1. Now with these systems, the more points you graph, the more accurate you're going to be. So my second equation, remember this is like plus 0. So my slope is 4 and my y-intercept is 0. Okay. So I'm going to go up 4 and over 1. And that's all I need to graph on this because this is where they intersect. And my solution is going to be the point 1 and 4. So that's our solution. Now, in order for it to be a solution, I said that that point had to be true for both equations. So I'm just going to double check. And I'm going to sub it into the first equation, y equals x plus 3. So if I substitute in my x and y's, I get 4 equals 1 plus 3. Okay. And then if I put it into 4 does equal 4, so that works. If I put it in the second equation, y equals 4x, I'm going to get 4 equals 4 times 1, which again is true. So we know that that's a solution to our system. Let's graph this system. So in this case, my slope is -1/2. And my y-intercept is 2. So I'm going to go up to 2, down 1, positive 2, -1, positive 2. I'm going to go up the same way. I'm going to connect my dots. And there is my first line. Okay. My second, my slope is -3, and my y-intercept is also -3. So -3. So I'm going to go up or down 3 and over 1. Going to go up 3 and over 1, up 3 and over 1. So now connecting the dots, a little better than that. There's my intersection, and my solution is -2, positive 3. Okay. Okay. All right. Again, these are in slope-intercept. The first equation, my slope is 3. My y-intercept is 2. So I'm going to go to 2, up 3 and over 1, down 3 over 1, all the way through. Graph that a little bit better. Okay. My second equation, my slope is 3. My y-intercept is -2, so I'm going to come down here. I'm going to go down 3 and over 1. I'm going to go up 3 and over 1, up 3 and over 1, all the way through. And what you might notice is that these lines are parallel. And remember from this chapter on writing equations, parallel lines do have the same slope, which means these are never ever going to intersect, which means we have no solution to the system of this equations. So there's no solution. Okay. Last example. Okay. The first one, or last example of this, my slope is 1/5 and my y-intercept is 5. And my slope is 1/5. And there's that line. My second line, I'm going to actually have to solve for y, so I'm going to divide everything by 5. And I'm going to get y equals x over 5 plus 5. Remember, x divided by 5 is the same as 1/5 x, so our slope is 1/5, and our y-intercept is 5. So if I go to graph that, you're going to see that it's exactly the same line. So that means that there is infinitely many solutions. Okay. And we're going to use the abbreviation IMS. So you don't break your hand while you write, because I know how you guys are. I don't want you to strain yourselves by writing too many letters. Right. So now let's take a look at a real world example. So Evan and his cousin are playing a game where they pick up colored sticks. Sounds like a simple game, right? Evan currently has 50 points and likes to pick up the red sticks, earning 8 points every turn. And his cousin just lost all of his points on the previous turn and has a strategy to catch up, getting all the white ones, earning 10 points per turn. In a certain number of turns, the score will be tied. How many points will each of them have? All right, so we're going to write, we've got two different people. We've got Evan and his cousin, whose name is Todd. All right, or his cousin. All right, so we're going to write an equation for each. So y is going to be our points scored, and x will be our turns. So right now, Evan has 50 points. In each turn, he gets 8 points. So his equation is y equals 50 plus 8t. His cousin doesn't have anything, and he's going to get 10 points for the sticks that he picks up. So his equation is y equals 10t. So now I'm going to graph this. The first equation for Evan, the y-intercept is 50, and the slope is 8. Okay. So if I go to 50, okay, and the slope of 8 might be hard to tell on this graph. Okay. So what we're going to do is we can just plug in some numbers. So, for example, if he gets 10, 50 plus 80 is 130. So we'll estimate 130. Okay. So if he gets 20, 50 plus 160 is 210. So up here, so do you see the pattern here? Every 10 points, we're going up 80. So from here, if this is 210, if I go up 10 more turns, I'm going to get 270. Right about here. If I go up 10 more, I'm going to get 390. And if I go up 80 more, I'm going to get 450. So here is my graph. All right. So now his cousin is y equals 10t, and he starts at 0. So every 10, he's going to earn 100. He's close. Not quite there yet. Oops. So we're going to be somewhere in here, and it looks like it might actually be 25 turns. Now it's tough to tell, but we can always check. So if we put 25 in, 50 plus 8 times 25 is going to be 50 plus 200, or 250 points. And then if we put 25 in the second equation, y equals 25 times 10 is 250. So our answer is they will be the same in 250 points. And that's in 25 turns. All right. So pause the video and you tell me, is this point a solution to this system? Okay. When you're ready, just restart and check your solutions. If I'm plugging in 5 and 2, I'm going to get 5 equals 2 times 2 plus 1. So 5 equals 4 plus 1. 5 equals 5, checks. So that works for this equation. And then if I put it in the second, 5 equals 3 times 2 minus 1. So 5 equals 6 minus 1. 5 equals 5. So that checks. Now, if I have the point, let's say 3, 7, let's check to see if that would be a solution, just to show you what it would look like for it not to be. So 7 would equal 2 times 3 plus 1. So 7 does equal 7. Checks for the first equation. But if I put it in the second equation, 7 equals 3 times 3 minus 1. I'm going to get 7 equals 9 minus 1. Well, 7 does not equal 8. So that's why that would not be a solution. All right, so you learned a lot today. You learned that a system of equations is equations taken together. Their solutions are ordered pairs. We learned to solve by graphing. Remember that we can have a point as the solution. We can have no solution when the lines are parallel. Or we can have infinitely many solutions if the graph's the same line. Have a math-tastic day.